it's a little intimidating, I think, to present this even to my close friends and colleagues here, because this is not a cool technical topic like we're used to, like vibe coding that we had last week from Padram. That was super cool and technical. But just to give you guys a little background for those who don't know me, so I did a PhD in information systems like 20 years ago or more from the University of Arizona. Yeah. Bear down, right? Bear down. Here we go. Doug went through the same program a couple of years after I did. Arizona is known for being a very technical program. And I started in a research lab called the Advanced Database Research Group under a professor called Sudha Ram, who to this day is just an outstanding professor, widely recognized in the world of database. I started there as a PhD student, like straight out of my bachelor's degree here at Utah State in business administration. So in hindsight, I was really unprepared for a PhD program like that. And I've told Reagan and some others this, that, you know, Sudha was very hands-off in terms of her mentorship. You know, she just kind of expected us to sit down in the lab and come up with cool stuff to do. And I needed someone to kind of guide me as what is this research thing all about? So all of this to say, I went through an evolution process during my PhD program where I quickly found out something about myself, and that was that I was not interested in just studying technology by itself. I wasn't interested in just researching databases and coming up with new ways of solving data problems. I discovered that I needed humans involved in the research in order for me to be interested. I ended up doing a minor in cognitive science, and my research has taken me down a few different paths, but they all deal with how do people intersect with technology in various ways? How do we use technology-mediated information to make decisions? I've done a lot of research on online communities and how people process information that they encounter on, say, online forums. We've even stuck people in fMRI machines and like analyze blood flow in the brain while they're looking at online forums, trying to figure out what's going on there. So all of this to say that for those of you who know me, the students who may be here, I teach technical things like web development, but my research is much more behavioral, dealing with the intersections of humans and technology. And I love the information systems discipline because there's room for all of that, right? You have more computer science type people and all these great professors of practice that we have that have these awesome technical skills. But also in information systems, one of the core topics is how do humans intersect with technology, and what are the behavioral aspects of that, the cognitive aspects, and that's really what fascinates me. So this, oh yeah, please.
Want to take questions at the end, or?
It's up to you. How much time do I have, by the way? Okay, I don't think we'll take that long.
I was thinking about this recently because I've had a number of conversations with both people in humanities and people in technical fields, STEM fields. And it always seems funny to me because it's only humans that do STEM. Right?
Say again, sorry.
I've been having conversations recently where there's this division between the humanists and the technologists.
Yeah.
But it seems so odd to me because it's only humans who do STEM. So it's like STEM is mathematics, engineering, they're uniquely human disciplines. So it always feels like we should push for greater integration. So I'm excited.
Yeah,
I'm agreeing with you.
I love it. So this paper, which I'm working on with my learning buddies. Reagan said I had to say that. Bob coined the term data buddies for his Data 3300 class. So this is learning buddies, Robert Mills and Reagan Sigurd, our two illustrious instructional technology faculty who have such great perspectives in that regard. This is an idea that I've actually had since I was a PhD student, and I'm ashamed to say that I just never pursued it because there was always lower hanging fruit, always other things to publish, and this was kind of a more abstract theoretical idea, and it always just got pushed to the back burner. So I finally just this last year said, you know what, it's time to do this. Let's get Reagan and Bob on board. Let's make it happen. So when I was working on my dissertation, I was working with an organization called Kaiser Permanente. Anyone heard of them? Big healthcare company, and I was studying mostly in California at that time. They were in the process of implementing a new electronic medical records system. It was a massive, multi-billion-dollar effort to implement this new system, to go digital with their electronic medical records. As you can imagine, an organization that size, any rollout of an enterprise technology of this scale engenders a ton of resistance and fear, right? Especially among, we found, medical practitioners who maybe don't have the technical skills, right? We found that doctors, for example, were a lot of them resisted this because they simply didn't want to be seen in front of their patients doing the two-finger pecking thing, trying to enter their notes, right? And now, of course, we have AI that can do all that for us, but there was a lot of resistance. There was a lot of challenges, as there always are with enterprise implementations. One of my very good friends is heading up the new ERP system over at SDL, and he shares stories with me all the time about how difficult it is. So there's been a lot of research on implementing enterprise systems in organizations. And my work at that time focused on what's called infusion, which is how do these systems become embedded in people's work practices? And what are some different ways that people adapt to these systems? As an offshoot of this, and I guess on a side note, as we were interviewing people who were involved in this process and people who are being trained in this new system, it became apparent to me right away that the task of learning to use this new electronic medical record system was a huge obstacle that needed to be overcome. And so, of course, the vendor of this system, brought in this small army of trainers, and they would come and sit down with groups of medical people and other personnel, and they would offer this training on the system. They were very good at knowing the bells and whistles and the buttons that needed to be pushed in the system, but they had no idea how these people had been doing their jobs using their old systems, right? They had no concept of that. And so it was really up to the trainee to bridge that gap, right? Here's how I used to do it in my old system. Now here's this new system I'm required to use. How does my knowledge of my old system map to this new domain, right? Totally up to the learner to figure that out. There was no support in that regard. So it got me thinking about this, and I'd been doing some research in related areas, and I'd encountered this literature on analogical learning, which talks all about analogies and how they're a fundamental part of how humans learn, right? We've all created analogies or drawn analogies to learn stuff. So I started wondering, is this analogical learning idea, could it be applied to a systems implementation where we could apply some of these principles to help predict and understand how people who are migrating from one system to another might be able to use their prior knowledge to better learn the new system? Or under what circumstances would this knowledge actually interfere with learning a new system? So that was the basic idea. So when I got together with Bob and Reagan, we wrote a draft of this paper and we submitted it to a workshop at MIS Quarterly. And I know a lot of you probably have no idea what that is. This is the premier academic journal in information systems, launched from the University of Minnesota, and has long been recognized as kind of the top journal. So we got it into this workshop. We got some decent feedback. We submitted this then to the Hawaii International Conference on System Sciences, which I know just sounds like a subsidized vacation. It's actually one of the most prestigious conferences in IS, and some genius just said it was going to be in Hawaii every year. So that's where it is in January. So that's also a bonus. But so we just found out yesterday that it got final acceptance. So we're excited to present it there. But so I'm just I violated the rules of this already. I've already taken a whole bunch of time just introducing it. I have 10 slides. But I consider myself half of the presenter that everyone else is, so I think the math works out, right? So I'll go fast, especially through the boring academic stuff. So let me ask, how many of us have experienced what I'll call system switching? And what I mean by that is you use a system to do a task at work, and either voluntarily or by mandate from the company, you're forced to switch to a different system. How many have experienced that in their life? Can you give me an example? Tell me, Lynn.
Green screen in the mainframe.
Yeah.
OS2 to Windows.
Yeah.
2.
Yeah, so lots of evolutions, right? Anyone have a more recent example than Lynn's? Kelly, please. EMS to course dog. So let's talk about that. So EMS has been used for scheduling rooms, right? And other things as well? Mostly scheduling. And now it's course dog, which includes scheduling, I guess, plus, yeah. So plus, it does curriculum now, right? Chris, we have to submit all of our course approvals through course dog now. So it seems like a broader system, right? So what's your experience been like? Has it been just super straightforward? Has there been training? So tell me, like, what's happened?
Why they took a program that was already historically slow and decided to add a whole bunch more things.
That's a whole separate issue that I probably can't solve. Yeah. What about?
I can't find it on course stuff in the classroom.
Yeah.
Does anyone else have this issue?
So Andy, tell me this. So you've attempted to use both systems. So on EMS, and I haven't used it a ton, but I recall that on the left there was like a sidebar, right? Where you would find the rooms. You could say, show me all the rooms, and then you could pick one and you could see where it was booked. I imagine the first time you went to Course Dog, you probably looked for a sidebar or something analogous to it where you could find a list of rooms, right? And it wasn't there, right? And so then you were forced to start looking around and seeing, sounds charming. All right. So this phenomenon, we've all experienced it, right? Like in the process of writing this paper, I had been using Mendeley as a citation manager. Has anyone used that before? I switched to Zotero, right? For various reasons, but I found myself like, okay, how do I create a citation? How do I do these basic things, right? And I was drawing on my knowledge of Mendeley to use Zotero, right? And we all do this when we move from Excel to Google Sheets or PowerPoint to Google Slides or whatever it is. We draw on our knowledge of the tool we used to use to try to understand the new tool, right? So as common as this is, it's really shocking to me that in the information systems literature, there's never really been an attempt to understand how does this process work, and under what circumstances does our knowledge of the prior system help learning versus hinder learning. And so this is the first attempt, and it's very much an attempt. It's a dipping our toe into this theoretical space to try to outline a model that would help to explain and ultimately, hopefully, predict where learning difficulties occur when it comes to applying old knowledge to new systems. Okay, so that's the whole shtick. All right, so how does the user's knowledge of a previously used system influence learning of a new system in a system switching context? We're limiting our scope at this point to operational sorts of systems that you would use to perform a work task, and we're looking at the same task, but moving from system A to system B. All right, cool. Okay, this is the boring part I'm gonna skip over. So lots of literature that tangentially applies to this. And for those of you who are students and maybe aren't in research, this is the fun part where you get to read hundreds of papers, right? And synthesize the literature and get into all of what's been done. These are the 4 areas of literature that have most direct relevance to what we're doing. The systems implementation literature is a very mature stream in IS. We know from this literature that learning shapes how users interpret systems functionality and ultimately how they engage with the systems, right? Lots of studies that have shown that. System switching has also been looked at, and we know from this literature that users incur costs when they switch systems, and we know that just from this room. It's not easy It's not easy to move from system A to system B. There's learning involved. There's also a host of other issues that go on that can present barriers to this. So that's what that literature tells us. The IS training literature, which unfortunately used to be a very robust field in IS and has since kind of simmered down. But Bob Bostrom, for example, and some of his colleagues did a lot of great work in the 90s that looked at how do we design effective training programs that support the way that people learn to use systems. One of the things that they noted in their work was that learning by analogy is a really key way that people learn systems. And they left it there, right? They didn't explore it any further. They just said, this happens, and someone else can figure it out. So that's what we're doing. Human-computer interaction. Tons of cool work on this, but pretty dated at this point, that looked at this idea of mental models, right? So when you and I use a system, we form this mental construct in our minds that represents what the system is for and how it works and what it does. And so this early HCI work really tried to flesh out what these mental models entail. And in a nutshell, they said, well, we have what's called taxonomic elements in our knowledge, where these is our knowledge of the parts of the system and the pieces of the user interface and what they do. And then we have procedural elements to our knowledge, which is how do these elements interact to allow me to complete my task, okay? So they also found in this research that analogy is a key way that people learn to use systems, but this is really old stuff. Like they were looking at how do people draw on their knowledge of typewriters to learn word processors, right? So we've moved a ways beyond that now, but not much has been done in the field since then. So our primary theoretical focus of this work is in analogical learning, and this is also a very rich stream of literature in cognitive psychology. Some of the prominent scholars here are Deidre Gentner and her colleagues, as well as Holyoke and Thagard, who proposed, these two researchers together have proposed two complementary theories about analogical learning, and I've tried to capture them in a nutshell here. Structure mapping theory means that when we learn by analogy, we try to draw connections with relational structures that exist, right? So a common example of this is if you're learning about electricity and circuits and how electricity moves through circuitry, people often draw on an analogy with hydraulics, right, and fluid mechanics. So how does water flow through pipes, and you have all sorts of things that can create resistance, and and you can draw analogies between all those constructs. So on the surface, those things don't have much in common, right? So water flowing through pipes, electricity in circuits, they don't have many surface characteristics in common, but structurally, you can draw a lot of parallels that can help you understand how this all works. And so structure mapping theory says when we do analogies, if we can recognize structural similarity between two domains, we will try to create mappings between them. And these mappings will form a foundation for us to transfer knowledge from what's called a base domain, like water, to a target domain, like electricity, okay? Multi-constraint theory is really similar in many ways. It says that, like structure mapping theory, structural alignment matters in creating these analogical mappings. But they also say that things like semantic similarity and pragmatic or goal relevance matter. And what that means is if things appear to be similar, even if structurally they may not be, that can still be a cue for us to start trying to think analogically about things, right? So like, glow sticks, for example, right? And electric lights, they work on very, very different principles, fundamentally different principles. But a novice, especially who sees those, might try to equate them together as working in a similar way, even though they're different. And then the pragmatic constraint says that if what you're learning helps you achieve a goal, and you've used something else to help you achieve the same goal in the past, you'll naturally try to create connections between those two domains. So I see multi-constraint theory as a more or less an extension in some ways of structure mapping theory. Okay, so we drew on these theories to outline a process of analogical learning, and these theories outline this process for us, and we're drawing on these. So there's these three primary stages in analogical learning: access, mapping, and transfer. Access means that when we're confronted with something new, we think back in our repository of knowledge and try to come up with examples of things that we already understand that we could use as analogs to what we're trying to learn. So access applied to information systems means when we're learning a new system, we access our knowledge of the old system, right? And our contention is this happens naturally as a process of learning. In mapping, the next stage here, we try to align elements of these processes. So we say, okay, here's how I did it in my old system. Here's the sidebar where I used to be able to find rooms in EMS. How do I now do that same task in CourseDog, right? And so we attempt to draw these connections. And these connections can be formed at the surface level, like similarities between how the systems look. And more importantly, they can also be formed at the structural level, which is how do these systems actually operate, and is there alignment between those? Transfer is when we actually, I envision it as knowledge flowing along the mapping channels, right? We've made these inductions about how these systems map to each other. Now we need to transfer our knowledge from one to the other. And this is where learning happens, right? This is where prior knowledge can either enhance our ability to use the new system or detract from it in some cases. All right, so with all of that, this is all built on what we call surface features and structural features. And they're defined here. Surface features are the things about the system that we can see and describe, right? So user interface components, the objects involved. So if, for example, you're moving from, say, Outlook to Gmail or something, there's going to be elements that you're used to, like an inbox, right? And a send mail button, and a compose mail window where you can type it in, and a box for BCC. And all of these things are elements of the surface of this system. And the structural features are how these things interact to help us perform tasks, right? So I click the buttons in this sequence, and this ultimately allows me to send an email to my colleague. And this is the step I follow to attach a file, and et cetera, et cetera. So if we look at similarity and difference between a surface and structural features, we can arrive at this kind of 2x2 quadrant, which I've been told every good theory needs a 2x2, right? So hopefully we're playing ball here. So along these lines, if we have high surface and structural similarity, again, this means that systems look the same and they also behave the same, right? So I think Excel and Google Sheets is a pretty good example of this, right? There are some differences, but by and large, you'll find similar menu options. Formulas work the same. Everything works pretty much the same. We call this literal similarity, right? These two systems are literally similar to each other. Our knowledge can basically transfer directly from one to the other. If structural similarity is high, but surface similarity is low, up in this upper left corner, we have relational similarity. And in these cases, learners may not immediately recognize that these systems behave the same because they look different, right? So in this case, access may be impeded. Like we may not immediately think of our old system because it looks different than our new system. But if we can recognize the structural similarities, then we still may be able to gain something from our old knowledge. On the lower right, we have what I think is perhaps one of the most interesting quadrants, which is mere appearance similarity. This is where systems look like they're similar, right? Leading us to believe that they should work similarly, but underlying that, they have very different workflows, they have very different processes for performing tasks. This is where I think learning difficulties are the most manifest, because we're led to believe that our prior knowledge should help, and therefore we try to apply it, and things quickly break down, and we find that it works totally differently. So this is called mere appearance. And then in the lower left, we have little to no similarity, which is the least interesting quadrant, right? This is where we just have to start from a clean slate. Okay, so yeah.
In some of your classes, sometimes you find that if they have no background on the topic you're teaching,
Right.
it's most beneficial for coming in with bad habits and things. So it is still an interesting quadrant.
Absolutely, yeah. Yeah, it would probably use the least analogical reasoning, right, in that quadrant, but still, I mean, definitely an interesting domain there. Okay, so this is super small, and I do apologize. So with all of this, I'm just going to click through this really quickly. So what we did in this paper was we outlined this process model by which people would move through each of these analogical learning stages, and we outlined research propositions at each stage. And I'm not going to go into the details of all these in the interest of time and not putting you to sleep, but basically what we propose is that when a person is confronted with a system switching event, meaning they're required to or they choose to move to a new system, they will first naturally call upon their knowledge of their old system. They will access the knowledge of their old system to help them learn the new system. We propose that just happens naturally. There's some research that backs that up that I won't go into now, but that's mostly what P1 is about, proposition 1. Then they move into the mapping phase, and they first examine the user interface, right? The user interface is our first encounter with any system. We see what the screen looks like. We see what buttons there are, what icons there are, what things are labeled as. We make inferences from what we see about what are called the affordances of these systems, meaning what can they let us accomplish, right? And if we see similarity between the old and the new, then we start to say, okay, yeah, this is going to work, right? I can use my old knowledge to learn the new knowledge, to learn the new system. So like when I went from Mendeley to Zotero, I saw that there was a add citation link, just like there was before. So all that stuff appears to line up. So P2 basically says when we perceive similarity, if there's high similarity, then we'll move on this left side, where we'll then move on to assessing structural similarity, which is, okay, if these systems look the same, do they behave the same way, right? So combining high versus low surface similarity with all the combinations of high versus low structural similarity, we arrive at these 4 boxes down here, which we call these prototypical learning pathways. Okay, and we've given them names down here. They're probably too small for you to see. I'll quickly outline them here. When surface similarity and structural similarity are high, meaning the systems look the same and they behave the same way, we have what's called an exemplar derivative learning strategy. This means that we can use the old system as an exemplar, and we can derive our knowledge of the new system directly from it. Think of it's just copy and paste, right? Okay, this works exactly the same way. I can just export all of my knowledge of system A and directly apply it to system B, no problems. If there's high surface similarity but low structural similarity, we call this model adaptive, right? This is where things appear to be similar, but under the hood, they function differently. So we're required to adapt our mental models of how the system works to accommodate the new system. If there is low perceived surface similarity, but high structural similarity, this will involve transfer of relational attributes to the system, but not really surface attributes, right? So we call this schema inductive. The reason it's called this is because we hypothesize that this will help us to induce what are called cognitive schemas. Cognitive schemas are more generalized knowledge structures about how maybe a class of systems work or a family of systems work. So we're starting to move beyond just system A to system B, and now we're generalizing our knowledge based on, because we can recognize that although these systems look different, they behave in a similar way. And then lastly is that box that we talked about before, where there's low similarity on both the surface and structural level. Not a lot of analogical learning happening here, but we have to construct our model from scratch. So that's the model constructed quadrant. Okay, so again, there's propositions, and I'm happy to talk about these in more detail for anyone who's interested, but that is the thrust of this. What we want to do with this is take this to now the empirical side of things and start to design experiments and other studies that will actually examine this in practice. Our hope is that by unpacking this black box, right, people have acknowledged that it happens, but no one's really explained how it happens, that ultimately, at this third bullet point, we can provide a mechanism to predict which training methods may be most effective. So imagine that Kaiser Permanente, way back 20 years ago, imagine that they could have somehow drawn mappings between their old systems and this new electronic medical record system. Imagine they could say, okay, here are the surface similarities between these systems. Here are the structural similarities, and here's where these systems diverge, right? Based on this analysis and these connections that we can draw, these are the learning difficulties that we predict for our employees. And these other areas are where maybe training won't even be necessary because it's just direct mapping, right? They could have saved so much money and time and effort with just a little bit more thoughtfully designed training programs that acknowledged how this prior system knowledge came into play. And so ultimately, that's my dream is to push this to a point where we can actually start to make predictions and help organizations design training programs that are more effective. Honestly, the biggest barrier in past years to this, in my mind, has been that sounds like a sucky task. Like, who wants to sit down and say, okay, there's an inbox button here and there's an inbox button there? That's horrible, right? That would be so tedious. Yes, I'm so excited. And I think maybe this is why I let this sit for 20 years. I was waiting for AI. That's the story. But can AI help us with this, right? Can AI analyze interfaces? Can AI analyze documentation of procedures for systems and identify the common points and the divergences in a way that could help us inform these training programs? I think it's promising. Padram agrees. Padram, we know from your presentation that AI can do it. Padram has probably done it already. What was that? I missed that. Well, yeah. I would not. If it were anyone else, I'd have my doubts. Padram, I think it would work. All right. Okay. So anyway, this just recaps some of the points that I've already made. So our next step is we want to submit a theory piece to MIS Quarterly. That's our goal. And we hope to do that within the next year, and then design just a tranche of empirical studies that will help us to validate this or steer it in a new direction or flesh it out. So if any of you have ideas from things you've read or other stuff like that, I would just love to hear what you have to say.
Since you presented.
Except for Bob. I've already heard his ideas. I'm just kidding. In Hawaii?
What? I don't know.
So what Bob doesn't say is we submitted another paper to IASIS, which is in Florida.
Yeah.
And he's going in October, so don't feel bad for him. Don't feel bad for him. Yeah, yeah. Lynn, please.
That is kind of primary end user audience.
Yeah.
Or enabling system that does this. Or, I mean, it seems to me that kind of system users who have a regular job and are just using an IT
Yeah.
to
Yeah.
get the job done, they struggle more than like technical people. And I mean,
Right.
whenever we transferred an Oracle user or a SQL Server user to a DB2 user, they started asking those questions. Okay, so this is the
Yeah.
equivalent
Yeah.
of this. They did that kind of automatically. So who's your part of
Yeah, that's a really good question, Lynn. And I'm glad you raised that point because there may be some individual level differences that aren't explicitly captured in this theory. For example, the people you're talking about, right, that are already technically savvy, I would hazard that they have a more mature mental structure that we might call that schema, right? That comes from exposure to more than just one system. Does that make sense? So if for example, I've used 5 different DBMSs, I can abstract from my experience across those 5 systems the core common features that all DBMSs are going to have. And so then when I move to my 6th one, I have that much more robust and generalized knowledge structure that I can draw from and say, even though I don't see the same button on this new system I saw on maybe my 5th DBMS, I can abstract and say, well, I know how this works in general, and so even if the button's not there, I can infer where that functionality might be. Whereas if you've only ever used one, like our 2100 students who are using Beekeeper Studio, right, as their basic SQL editor, there's been a couple students that I've had to introduce to SSMS, SQL Server Management Studio, because Beekeeper won't run on their systems. And they're like, whoa, this, to me, they look the same, like, because I know how to use both, right? But to them, it's like, well, where's the run button? I don't see it down here in the corner. Well, it's the execute button up here instead, right? So I think the primary audience for this could span that range of very novice users who don't have a lot of experience across systems to those who do. I think what we'll see though is that they're following different paths through these prototypical learning types. But ultimately, the audience for this would be organizations implementing new systems, like SDL is doing right now, right? They're rolling out this new ERP system. They're facing major challenges on many fronts, but learning is one of them. And how do we streamline that and make it easier? Yeah, Andy.
Looking to Doug talks about in his class, it's cost of adoption.
Yeah.
You're also kind of addressing cost of adoption with this.
Yeah.
My experience with moving from system to system is often a smaller agile system to a larger vendor system.
Yeah.
Like Microsoft Suite. You're either going from that to something smaller like Slack, or from Slack to Microsoft because it's been imposed upon you.
Yeah.
And if you had
like Teams.
you have like an AI that can go through the docs of each, find out main or core functionality of each, and then give you steps on how to use that in the other. If this was a product one day, which is kind of where mine went, sell it as a lower cost of adoption because the AI will assist with you in faster getting to the features you want them to do faster.
Yeah, absolutely. Yeah, I mean, imagine an AI enabled training tool where you could feed in data on your old system and data on your new system and get this customized training program that actually leverages your prior knowledge and doesn't just leave it up to you to create those connections. I think that's majorly promising. Yeah. Yeah, well, that would be wild. Yeah, I hadn't thought of that. That would be cool. Yeah.
SDL, I know when we worked there for a year and a half, SDL has some software where they just, for their training purposes, they just have an analyst go through and do your job when you do, or they record some, and they can have meditations like that. All of that can be fed into an AI.
Yeah, absolutely.
So you wouldn't even need a huge training set. It would be as simple as do your job and we'll record you.
Yeah. Yeah, that's a great point. Thanks, Andy. Any other? Oh, sorry, Carly.
What sorts of measurement tools are you using
for the empirical side of it? That is a really good question. So it's TBD at the moment. We're brainstorming, right, these ideas, but I think experiments could be designed. The trick will be to design mock systems that can be manipulated in very specific ways, right? So we need to do a little bit more work on solidly fleshing out exactly what types of surface features we're talking about. There's a whole range of user interface components, and are some more important than others. All that stuff remains to be kind of fleshed out. But I could imagine doing an experiment where, you know, if we can design a system where certain interface elements are parallel to each other, but then the system behaves in a totally different way, like the sequence of steps you follow is completely different, versus here's a different interface, but if you can get past that, you'll see that the process is the same, right? I think we can pretty easily measure learning outcomes. For example, time that it takes to complete the task in the new system, satisfaction, you know, with the training, you know, testing the user's knowledge of the new system with a battery of questions. There could be a lot of ways to do that, but I don't know. Maybe. Yeah, maybe eye tracking. Actually, I love that idea because, you know, do you see your eyes going to where it used to be, right? Yeah, I love that idea. All right, Doug's going to set me up. Yeah, yeah, that's a great idea. I appreciate that.
Interesting to see if you could actually tease out in your outcome measures the learning paths that they're in too. If you actually, you have this proposition about, hey, they're going through these learning paths, not only the outcome measures, but the document, they're actually taking the channels that you propose.
Yeah, I love that.
They're taking, whether that's like, you have them reflect, I mean, that's tricky because there's probably not an instrument for that, but that would be.
Yeah, that makes me think too, like a friend of ours, Jeff Jenkins, down at BYU, has done a lot of work on mousing, right? So, I mean, and it's shocking. I mean, they've launched a multi-million-dollar company based on these basic ideas, but, you know, tracking users' mouse movements that reveals things about what they're thinking and how they're interacting. So, yeah. Yeah, absolutely. Yeah. Yeah. Absolutely. Yeah.
Keep thinking about this, you kind of touched on it with the theoretical framework, your awesome 4x4. Is there any recommendations that come out of this? Because in my mind, we touched on this a little bit, is there is relational similarity, but not structural similarity. It's like the danger zone. So people use it in a way that they think will work, and yet it doesn't.
Yeah, so that would be mere appearance, right? If there's relational similarity. Anyway, well, so yes, the short answer is ultimately we hope there are recommendations that I mean, it's theoretical right now, but if we can provide something to organizations that lets them say, paint a broad picture and say, okay, overall, this system's transition can be classified as relational similarity or something like that, right? Then these are the types of learning difficulties that we will anticipate will happen. Here are the specific parts of the systems where we anticipate those will happen. And here's how we can design training programs that will mitigate those challenges. That's my ultimate hope with this work, is that we can get to a point where it's mature enough that we can say, yeah, for this functionality, this is a mere appearance issue. For this, it's going to be a relational issue. And then here's how to design your training programs. That's where Bob and Reagan come in. Right. So, yeah, exactly. And that was on the slide. I mean, informing systems design is another layer of this where, you know, to the extent that it makes sense, why not just design the system in the first place to track with what, and you know, like Google Sheets is probably designed to look a lot like Excel for a good reason, right? So, yeah, I would.
Is it specifically within use of software that you're interested in?
Yes. Tell me more though.
So here's what I'm thinking, because think about, let's go one step back to the software developer. I find this unique problem here because they have to have eventually in their mind a mental model of the code they're going to write.
Yeah.
And once it's complete to some satisfactory level that the stakeholders decide upon, some human has a mental model of that. But if we back up to their problem, they have to have sort of some sympathy for the end user.
Right.
But once the software is written, there's now a communication problem between them that the software is somehow mediating.
Yeah.
And I'm deeply fascinated in this problem of the human mind and technology and computation. But what I wanted to ask is there any literature about the software engineer's problem that,
Yes.
that could aid your problem on the other end and phrasing it as a communication problem between these two humans mediated by technology?
There definitely is literature on that. And, you know, it's a slightly different issue, this issue of, as you articulated, the system is kind of this mediator between the designer's mental model and the user's mental. Right, exactly. So that's an issue of transfer between two different people's, what's in two different people's heads, which isn't really a domain of analogical learning per se, because with analogical learning, we're drawing on our own knowledge, although there could be explicit analogies that could be introduced into that process, where, say, the designer could say, when you try to use this, think of this analogy, or, you know, think of that analogy. So I do think that there could be connections there. I haven't explored those in great depth yet, but yeah, I'd love to talk to you about that.
Because I wonder if AI generated human programming as a pair is exacerbating or helping this problem. And
Yeah,
I don't
that's a
know.
good question.
I think the jury's out on that. I don't know if we know.
Yeah. Yeah, would AI be able to, yeah, design systems being informed by something like this, where it could actually enhance the design? Maybe so. Yeah. Thanks, Tyler. I appreciate that.
We have time for one more question. So I asked from the chat, you said, is there a point where people stop building base models? I'm thinking of my grandma who grasps iPhone concepts quickly when I relate it to a typewriter, but struggles a bit more if I relate it to the laptop, which she's had for years.
So the question is, do they stop building base models?
I'm not sure who's thinking in terms of in your life, or just like maybe at some point you no longer think about the base model, it's been like replaced by the new model.
Yeah, that's a really good question. And there's this whole issue related to that of certainly when we learn to use a new system, the previous system is not our only source of knowledge, right? We may have used other systems to do other things that seem similar. We pull that knowledge into. So what we're looking at here is admittedly a simplification, because we're looking at this one issue of system A to system B. But here's two system A's, right? It's what did you say? It's a typewriter and a laptop, right? So which of those gets the front seat in the analogical learning process? I don't know. Probably the one that she feels most comfortable with and knows the most about. Could there be a point at which she's done her laptop enough that it would now become the primary base? Probably. But yeah, I don't have a great answer for that, Toa. Sorry. That's an interesting question, though. Yeah, Kim, please. Yeah.
Yeah.
It switched over.
Oh, yeah?
And my nephew is, excuse me for my health. His child had to go to the emergency room. And when they went, they couldn't, everything was fine, but they couldn't check her out. They couldn't check her out because the app was, the person facilitating it didn't know how to use it.
Yeah, yeah.
They used, it's now called My Chart.
Got it.
So it all comes back to what you're saying. It has to be successful. Whoever's going to be using it to transfer that knowledge.
Right.
And the people in the emergency room were unable to check her out for like 2 hours because they couldn't use how nobody had encountered or thought about what you're saying. Is there going to be a problem when this goes through? It's whoever is going to know how to take the Intermountain Health.
Yeah.
But what
Yeah.
changed over. But I thought that relates completely to what you're saying.
Yeah, yeah. Yeah, thanks, Kim. That could be a serious issue too, in the medical field especially. Yeah. Yeah, there's just this pervasive assumption when it comes to training that we just start from carte blanche, right? We just say, oh, we're just assuming you're an empty vessel and we're going to dump all this systems knowledge into you. We're going to tell you what to click, but that's not how people actually approach the learning process. They bring with them their previous knowledge, and it's just a natural human strategy to try to apply that, right? And so that's really what this is all about. Yeah.
It's an hour. Thanks a lot.
Woo. Hey, I really appreciate you guys coming. I would love to talk to you one-on-one, and thanks for your support. Bob really needs it, especially. No, I'm just kidding. I just want to make a shameless plug for the students that are here. I'm working on another research project with a colleague at San Jose State. We're exploring multiple team membership scenarios where people are parts of multiple simultaneous teams. We're studying how attitudes and team norms around the use of AI spill over from one team to another. We're designing some experiments around that. I have some money to hire a student assistant to help us develop some experimental protocols and some systems. So if you're a pretty good coder and you're kind of interested in maybe doing some research with us, let me know. Let me know. If you can use AI like Padram, I'm interested in talking to you. So come and chat with me. Thanks, you guys. Appreciate it.